Welcome to Networking Field Day. The presentation that you are about to watch from Anuta Networks is being attended by a group of invited delegates who are here to ask questions, make comments, and offer their opinions about the technologies that you're about to see. For more information about this event, please visit our website at techfieldday.com or our YouTube channel at youtube.com/techfieldday.
So in the interest of time, what we'll do is we'll get to the portion where we develop a service template, deploy a service template, and make it part of the catalog, and order the service so that we can see the end-to-end flow. And there's a significant portion of groundwork we have to do for the services to work. We have to do the discovery. We have to make sure that the infrastructure is reachable, inventoried, all the interface information, existing configuration to understand brownfield deployment. All of those aspects we'll try to skip them, and we'll look at service deployment. So what we are seeing on the screen is the earlier case that Kiran was making as to how do we want to productize a service. It could be application deployment in a data center environment. It could be a traditional CPE deployment. It could be a day zero onboarding where I'm deploying a bunch of standard templates like SNMP, Telnet kind of configuration, or I'm deploying an SD-WAN kind of a branch. So from a MSP point of view or a large enterprise point of view, there's going to be this role within the organization that's a product manager that's trying to productize a end service to his internal consumer or for an external consumer. So how it starts out is they're going to do an internal research, or they're going to adopt a validated design, Cisco validated design, Juniper validated design, or Brocket validated design. And from that validated design, they go make their own customizations and they start deployment plans. Sometimes it takes anywhere from weeks to months. Sometimes it may be close to a year, depending on the complexity of what they're deploying. So for a product or for a service like a Cisco iWAN, it takes a long time to test it out, to go and generate configurates, to go and build internal automation scripts. If at all somebody human needs to deploy, it just takes that much longer. So how do we streamline all of that process? So within Anuta, what we do is for some of the well-known use cases like iWAN deployment, data center deployments, we have some standard models. These are Yang models. We call them as starter kits that we have developed, and we make that part of the base platform. And these models can be adopted by the customer as they are, or they can go and make adjustments. And the adjustments can be made using our SDK. We have an SDK engine that will allow us to go and modify the Yang models, to go and generate code, the Python code and the adapter code that's required. All of this is done during the DevOps activity. And once it's tested, now what you do is you go deploy that into the NCX platform, and then it is ready to be consumed by the operations teams if it is internal consumer, or through an API into a self-service portal through like a ServiceNow or other ticketing systems can order the APIs. So this is a very high-level flow as to how things would happen in a real environment. So we would have a development staging environment where the DevOps teams are taking the kits and then developing what needs to be deployed, and then we're going to have a production environment where they're consumed. So what we're going to look at the demo is we're going to look at the production environment where the service model is already developed, and we're going to go through the phase of deployment and then ordering it. Any questions before we get started?
I've got a quick question. How do you handle, so let's say I have 1,000 locations and I've got this template for, I want to put out my 1,000 remote locations in like a large enterprise. What happens when you get the snowflake? Some engineers like, oh, we've got this problem, and I go log in, and suddenly I've got a piece of code in there, and I have a snowflake, amidst an army of clones. How do you deal with that?
Yeah. So in that case, what you do is you parameterize a portion of the config, and that parameterized portion of the config may be invoked only if the location is so and so, northeast or maybe south. That's how you do that. And if the requirement is dramatically different, where you're talking about like gold, silver versus bronze versus gold, you have a different template altogether, gold, silver, and bronze. But if you have small differences, you can go into the gold and say you have location-specific attributes that you can go and tweak, and it's all something that we can accommodate within the Yang model.
But is it something that you can detect? Is it something that you can see if somebody actually made a change here and we recognize this is now different from the others post-deployment?
Exactly, yeah.
Okay.
Yeah. Especially in enterprise environments. Across customers, it's a no-brainer.
Sure.
Everybody is different. But within the enterprise also, they don't grow organically. We see pretty much all the time different vendors all over the place, yeah.
Okay.
So I'm going to keep this presentation handy. I'm going to switch back and forth from the presentation to the artifact that we're going to run through, the YANG models. And that questions are welcome at this stage, but let me just open this up. So on the right-hand side, I'm going to keep the modeling slide, okay? So at the bottom of, it won't be legible, but I just will try to make it bigger. So if you see the overall modeling stack, we have the device mapping at the bottom of the stack. We have Cisco as a vendor, Arista as a vendor, and we have others, possibly others. And we have this as a common device model, and then we have this as a service model. So deploy L3 VPN, deploy CPE, deploy application is here. Create VRF, create VLAN, create SVI is here. And how do we define the device model? So if you see the device model itself, it's described in YANG. So the model that you're seeing here is how do I create users, how many users I can have, and how do I map this abstract YANG model. So this user YANG model here maps to this common model here, okay? It may not be legible, maybe let me switch back and forth using tab. So the common model here maps to this YANG model here. And depending on the complexity of what we're trying to deploy, there may be a model for create firewall, create application, create VIP. All of those things are going to be modeled in YANG.
Can you make it a little bigger? Like
A little bigger, okay. How do I do that?
or a lot bigger?
A lot bigger.
A lot bigger.
You Zoom. Or we can just trust you
Yeah.
in the interest of time.
How about now?
Better.
Okay. So this is the YANG abstract YANG model, and this maps to this box here. And then once I have an abstract YANG model, I have to now say how does it map to each individual vendor, and this is how it maps to Cisco iOS XC platform. Okay. So if it is a CLI-driven device, and this XML that we are seeing here maps to this area. So all this work is typically done by Anuta. And in some cases, we are going to work with SI partners and vendors themselves to go and provide this abstract YANG model and these concrete mappings. So a significant knowledge base already exists for the device layer communication. Okay, and this is what takes care of at this layer. So we have an abstract YANG model to tie in. Now we can work at the next layer. So once I have this abstraction done, at this layer, I can go and say create VLAN without worrying about who is the actual vendor. Is a vendor taking CLI as an action, API as an action, is abstracted at this layer. So if you look at a service model itself, we can go to the iWAN service now. So here I can see the iWAN service where let's look at a VRF creation in this one. So if you see here, we are going to create like a route injection. So it's a very default, a very abstract way of saying that what is that I would like to do as a part of a bigger building block. And like here, I'm actually mapping from service layer to the device level abstraction. So once I go to the service model, this is also in YANG. We are looking at this one now. And this is going to be using some of the foundational constructs like the building blocks, create VLANs, create SVIs, and bringing them together into a higher building block that we call as a service model. So going back to that iWAN service, this is about 3,500 lines of YANG model. And this iWAN service model maps to the Cisco iWAN document, the Cisco iWAN 2.1 deployment guide, and this whole document has been converted to a YANG model that's about 3,500 lines, and that's the starter kit we make available as a part of NCX. And customers go to this model, they like it as it is, they want to deploy a standard template, then it's good to go, or they want to go and make some fine-tuned adjustments based on their own operational requirements. They go modify this iWAN service, make that as their own version, 1.1, 1.5, whatever it may be, and now they have a service model. So we have the device abstraction, which is predominantly developed by Anuta, and we have a service model where starter kits are given by Anuta, but the customer has full capability to go define all of these areas if they want to go do it. If they want to be self-sufficient, all of these are available in the SDK. That's also possible. So once we have a model, so let's say the device models are there, the concrete mappings are there, and then I have a service model. Next, I take this model, I package it, and then I deploy it into the NCX platform. Now we're going to log into the NCX product, and we will look at what packages have been deployed. So if you see some of the device packages here, so the device packages, you can see all the different vendors that we have support for at this layer. They're showing up as device models, and I can also see service packages and since it's a demo VM, we have only deployed a bunch of services. So we have a service model for L3 VPN. We have a service model for L2 VPN. And we have a service model for Cisco iWAN. So all these service packages have been built. They have been tested over probably weeks of time, and then they're deployed into a production environment. So at this stage, the iWAN service or some of the services that we have developed and deployed are ready for consumption. So once a package is deployed into the NCX provides persistency. That means that if you can go and instantiate against that service, I can go and instance 1, instance 2, instance 3, and the NCX will be able to understand the YANG model and create persistency. That means we can go and store data against that instance, against that service template. And then we provide API, and then we provide UI also. So for example, if I go to the services now, we can see all the services that we have deployed now. These are service templates. We can call this as a catalog. And this catalog can be ordered within the NCX portal right from here, or they can be consumed via API into a northbound portal like a customer self-service portal, or it could be ServiceNow or some of the ticketing system or portal. So if I step into the iWAN service, so this iWAN service is a representation of the model that we have defined here. So if you see some of the aspects that are being shown here to deploy an iWAN domain, all of these names, properties, all of these attributes are coming from this iWAN domain here. So if I go to this definition, so they're all coming from this model file. And to get this done, all the customer needs to do in this case is they have to develop the YANG model, or they have to adjust what we gave them, and it's pretty much good to go. So at this stage, we now have a iWAN domain service available. And let's say they have different variations. So what they do is they go and parameterize it. For example, once I step into one of the instances that we deployed, all of them, if you see here, the different aspects that they have modeled here, all of them, if I go here, all of these different entities may apply to all sites, may not apply to some sites. For example, some sites may be HA. If I go to spoke domain, some sites may be HA, some sites may be non-HA, but all of that have been articulated in the YANG model so that the UI is rendered automatically and the orchestration can also follow through. Any questions?
I've got a quick question. I'm just curious about the origin of Anuta because it kind of feels like OSS in the service provider world. It's like you guys took, like Carl mentioned, service providers have these army of developers that take, okay, here's my OSS, my provisioning, and I'm going to go do these things, but I've got to have 20 developers to go deal with all these different things I have in my network, and you've kind of compartmentalized that. I'm just curious, are there origins in OSS for this product, and that was your target, or did it come from somewhere else?
So we had a background in configuration management before. Abstraction has been some of the things that we have done in our prior professional life. So we're more from the device side, and then NMS, I would say EMS, and configuration management.
Okay.
So let's take the example of deploying a spoke node. So let's say in this particular example, we have already deployed an iWAN domain. We have already onboarded the hub nodes, and let me briefly go through the hub nodes. So we have already deployed the hub domain, and now I want to deploy the spoke nodes. So we already have onboarded spoke 1. So I want to onboard a new site. It's a branch location. And in the interest of time, what we'll do is we're going to load a predefined template, and it's going to do all the data fill into all the different properties. And all of these things that we're seeing here are coming from the YANG model. And if you have to make any differences between site 1 to site 2, maybe we're not going to, again, say, let's say, I don't require this feature on a particular site. We can do that customization. We don't need a brand new template. So we can parameterize and drive quite a bit of these stations from one standard template. So once I do the data fill, for example, this picture itself is driven by this YANG model. So customer is not doing any development other than developing the service model, and the UI is going to be coming out of the box for free, and the whole UI API is also going to come out for free. So if I click on this node, I can go and further customize what I can do on this node. So in this particular case, this node is a router, is a virtual router, is a VRF, and this is a LAN segment, and all of these are described in the YANG. And also on this link, if I click on this link, I can go and describe what my link properties are on the WAN side. So depending on your use case, in this case, it happens to be the branch deployment. In the other case, it may be deploying a VIP address. So if it is a VIP address, I have to do a whole bunch of things that are completely different than what we're doing here. So based on that, things are going to be different. If I click on this icon, again, so I have some properties here, and the internet side properties here. So once I click OK, now the NCX got all the data fill for all the properties that it needs, and then it's going to go through a end-to-end orchestration flow. And this is going to go through different phases. It's going to reserve the resources. I need 1 VRF, 2 VRFs, I need 4 VLANs. I need to go and bring up a new virtual router, new virtual firewall. All of those aspects are going to be taken care as a part of this orchestration flow. And not all of it is going to come out of the box. In some cases, customers have to go and write some Python glue code. Let's say if they have to go and secure an IP address from an external IP address management system. We could do that within NCX, integration into an IPAM tool, but let's say for whatever reason, they want to go and grab an IP from a text file. So they can go and write a custom glue code using Python to go and do some of those business logic. But ultimately, all of those things are done by the time we get here. So it's going to take a moment for this to transition to 50%, and then once it's at 50%, admin can take a look at what are the different CLIs that we're going to generate for this particular deployment, and he can either approve it or he can reject it based on what his choice is. But at this time, now we have onboarded one branch site. Going back to your earlier question, this may be driven from API where you fill in the data for 100 branch sites or maybe 1,000 branch sites. At this stage, the NCX would not care. It's going to be driven by the API to say what is that you want to deploy, how many API calls is that going to translate into, and then the deployment happens. And we do support some of the bulk operations, but that is also a part of the product. But typically, the not-bound system also gets control how the orchestration happens. Any other questions?
Do you have special handling for management access? Do you mark interfaces and VLANs that are used for management for make sure you don't saw off the branch you're standing on, kind of thing?
Right. So what happens typically is the management network is not made part of the data flow. They are actually left out from the inventory, and that's how typically it happens. We don't get to discover the management IPs. So that's actually the prerequisite before we even get here. Actually, let's wrap this up and we can get into that one. So the service we just ordered is in a waiting state now. What this means is that the admin or the not-bound technical system can act upon it. So in this case, this is the payload that we submitted through API to deploy a spoke. And then these are all the various different commands that we are able to generate from this Yang payload. All these commands, and I can go and say assign a particular approval. And typically, the approval on all of this mechanism happens in the ticketing system. But if there is a customer that wants to use some of this built-in, they can use it. They can say approve.
This config compared against what's already there?
Yeah. So if it's already there, we are not going to push it back to the device again. But typically what happens is the device accepts the configuration. If it's sent also, it's going to be no op. So once I deploy the service, it's operational now. And the spoke node is going to come up. It will take just a moment. And when it comes to your question, so the discovery is going to control what aspects of the network we're going to be working with. Is it the management? Is it the data? And even within the data, what is the IP range we're exposed to? And then that's the portion of the infrastructure that we'll be working with. That is something that we can take care of early on. And before we go there, this is a spoke node that we just onboarded, the spoke 5. And then I can step into the node. And this is not just one-time deployment. This is day 0. And then if you want to go do day 1, I go to the spoke node. I can go add static routes. I can go add route maps. You can just keep on doing day 1 and day n actions also. So it's day 0 for the branch onboarding, and just the life of the service you can keep on doing. There are lots of other aspects like reconciliation that Kiran was touching upon. Just briefly, this is fairly important. So if you see there's an action that happened on the SRX firewall where somebody possibly modified something that they're not supposed to, then you see the actions like this. Do you want to overwrite NCX, which means the device is a master, or do you want to overwrite the device, that means NCX is a master, or do you want to ignore the change? These kinds of things are also going to be done on a day in and day out basis. And this is exactly where the monitoring is important. We need to at least know that somebody is logged into the device and somebody is modifying the device. That much we need to know. And that is something we can get it through an syslog or SNMP trap, so that we know when to go and collect the latest and greatest configuration from the device, do a delta so that we know what happens.
So that brings up a good point about change control. How is change control handled, managed, and how do you audit that? Is that part of the solution, is being able to audit? This guy just went and pushed this and broke 3 sites, you know.
Right, exactly. Yeah. So if you see the compliance is actually built as a part of the product. If you see this one, this is the compliance at service level. I onboarded a site, and then later at some point, somebody removed a configuration. At any given point of time, you get to know what sites are out of compliance. And the compliance is more from service point of view and standard IPsec policy point of view also. The standard IPsec policy could be, I don't want to see the default username passwords anywhere across my network. That is something you can do like a device level compliance. But so there's 2 levels of compliance we separate, as you can see from here. Compliance is at service level. This is the red one. The orange one is at the device level. And so typically, any aspects of configuration management day 0 to day n, and services that overlay on the day 0, all of that is part of the products space.
So I have to cut short the discussion. Yeah. It's, once you get into the details, there's a lot to share. I want to end by saying that Anuta provides orchestration for multi-vendor physical, virtual, SD, and infrastructure. And thank you for going through the presentation.